Finished solution to this here beside me, but I thought it's kind of hard enough to explain. So I thought I should explain it as opposed to just kind of giving you the answers. I also found the marking scheme online. It's from like a 2016 or something mock paper, so at least I know my answers are right, and I'm also snipping the questions from there because yours were a little bit blurry. Alright, okay, so 1st of July 2014, Meg borrowed 60,000 from the bank. She chose a payment-free option on her loan for 18 months. The bank charges interest that is equivalent to an annual percentage rate of APR 4.75%, and show that Meg owed that much money on January 1st, 2016. So starting on July 1st, 2014 and going to January 1st, 2016, it kind of says it, 18 months that we're talking about. So this is just, am I on the right page even? The page in the table book. So when you're doing these, you're working between the financial maths pages, which is page 1331, and then also the sequences and series pages, which are here. Mainly because you need the, like this one here. So 22 and then 30 and 31. Anyway, so for this one it's compound interest, so it's that one. So F equals P bracket 1 plus I to the power of T. So P is the money invested, which in this case is 60,000 euro. 1 plus 4.75%. Yeah, 4.75% is 0.0475 because when it goes into the formula it has to go in as a decimal, so you divide it by 100 to turn it into a decimal. And then to the power of T, so this 4.75 is a yearly rate, so that when you put your time in, you have to put your time in years. If that was a monthly rate, you put your time in months and so on. So your time goes in years. 18 months is 1.5 years. And if you type all of that in, I'm just going to do it to make sure. Power 1.5 multiplied by 60,000. Yeah, you get 64,325 euro and 37 cent, rounded to two decimal places or rounded to the nearest cent. Okay. Right, so that's the first part. Second part. Okay, so Meg agreed to repay the loan. Sorry, I'm just looking at my sheets here. Meg agreed to repay the loan plus interest from January 2016 by a series of equal monthly payments over 10 years, payable at the end of each month. By choosing a payment-free option on the initial period of the loan, Meg also agreed to pay a monthly interest rate of 0.425% fixed for the term of the loan. Find correct to 5 significant figures the annual percentage rate that is equivalent to a monthly percentage rate of 0.425. Right, so when you're doing these, you kind of use that same formula as up above. So it's this formula. Sort of. You always let P be 1, so you're essentially investing €1. So you invest your €1, 1 plus I, and here what we have is a monthly interest rate that we're trying to turn into a yearly interest rate. So a month is 1/12 of a year, yeah? And if you invest your €1 at 0.425%, so literally you take €1, divide it by 100, multiply it by 0.425, and then whatever the answer to that is, you add the 1 back on. Okay, so you're literally getting 0.425% of €1 and adding it back on, and you get 1.00425. So if you invest your €1 for 1 month, which is 1/12 of a year, you will end up with this much money. Yeah? And basically, you kind of work this so that what we're trying to figure out is what's I. Okay, so the 1 you can just forget about, divide by 1, it won't impact anything. And it never does, which is the reason why we choose it in the first place. Okay, so this is what I have. I want to get rid of the power. So to get rid of the power, you use roots. So if you want to get rid of a square root, you use, or if you want to get rid of a square, you use a square root. A cube, you use a cubed root. So if you want to get rid of 1 over 12, you have to get the root 1 over 12. Okay, so you're going to use your calculator to do that. So on the left hand side, that's going to cancel that out, and you'll just be left with 1 plus I. And on the right hand side, I'm getting 1 over 12 out 1.00425. So I am getting, where's that? Yeah. So I'm getting 1.052209. And then, like I said, I'm trying to get the I. So I'm going to take this 1, bring it across the equals, and it becomes a minus 1. So I get Y is 0.052209. That's your I, which is your percentage, but it's written as a decimal. So if you want it as a percentage, which I think they do find correct of 5 significant figures, the annual percentage rate. So we need to get it as a percentage. You multiply it by 100. Oh no, what should I do? Anyway, you multiply it by 100, 1, 2, and you get 5.2209%. And that's 5 significant figures because it's 1, 2, 3, 4, 5. Okay, so that is how you turn a monthly interest rate into a yearly interest rate. You acknowledge the fact that the month is 1/12 of the year. Okay? And there's your answer there, so that's right. So then calculate correct to the nearest cent. Calculate correct to the nearest cent the amount of monthly repayment. So when you're trying to get the amount of monthly repayments, we'll go back over here. Use this formula here. I'll just snip it in so we have it. So this is the formula you use to find the amount of the payment. Now, this P here always annoys me. Really, it should be here. Okay, and that's just the way I do it. Because it's technically P over 1, so the P belongs to the top line and the 1 belongs to the bottom line. So I'll just do it with the P on the top line. So to work out the amount of the payment, the principal, so that's the money that she is borrowing. So she borrowed €60,000, but then did nothing for 18 months. So by the time she starts repaying it properly in January 2016, she actually owes this much money, the 64,000. So her principal, the starting amount of her loan is €64,325.37. The interest on the loan, so here we're talking about months, and her monthly amount here, so monthly interest rate is, so it's the 0.425. Again, when it goes in here, it has to go in as a decimal, so it's 0.00425, because to turn a percentage into a decimal, you need to take that number and divide it by 100. Okay, so that's where that's coming from. Next part is 1 plus I. So that's going to be, sorry, I've lost the cursor. It's going to be this plus 1, so it's 1.00425. The term of the loan was 10 years, was it? Yep. So here. So the term of the loan was 10 years, but remember that she's paying it in months. So 10 multiplied by 12, because there's 12 months in every year, you're talking about 120 repayments she's going to have to make. Okay, and then then the bottom line is 1 plus I again, which is 1.00425. To the power t is 120, and then minus 1. Okay, and if you type all of that in, I think you get €685.42. And that's her repayment. Yep, there it is again. Okay, so moving on. Where am I going to now? Okay. So Meg's bank has agreed that from January the 1st, 2022, I'm going to reduce her APR to 4.4%. So APR is annual percentage rate. So that's a yearly figure, not a monthly one. For the remainder of the loan, if she makes all her payments up to date and on time, the outstanding amount would be repaid in equal monthly repayments over the remaining term of the loan. By finding the present values of all her remaining repayments on January 1st, 2022, using the sum of geometric series, calculate how much Meg still owes the bank. Okay. So what we have to do is work out her remaining payments if she wasn't given this offer and if she was still paying the money up here, which is 0.425% monthly. Okay, so let's try and figure this out now. Oh yeah, so up to 2022. So what are we talking about there? So 2022, 2020, oh crap, 23, 2024, and 2025. Isn't that right? That's 4 years. That's what's left. Sorry, now I'm just gonna tidy this up a bit. Okay, so she started the loan in 2016, and it's a 10-year loan, which brings her up to January 2026. So it's January 2016 up to January 2026. So her last payment will be made December 2025, essentially. In January 2022, there's 4 years left, which means she has already paid 6 years of the loan. Okay, we'll just keep that there because I think we'll probably need that going forward. Okay, so the remaining payments, if she was still paying the old interest rate, as in, so what we're trying to figure out here is how much does she still owe between January 2022 and the end of the loan. What does she still owe? Okay, so that total amount that she owes for the last 4 years of the loan, and it says to do it as a geometric series. Okay, it also tells you to use present values. So present value, you can see it here. This is the formula for present value. Okay, just snip that in as well. So this is your, I'm just going to, I'll throw it over here somewhere. Right, that's your present value formula. Okay, so the money on top is the amount she's paying each month, which was €685.42. It's going to be with 1.00425, so it's 0.425 interest, and then there's a plus 1, so it's 1.00425. And that first payment there will only have 1 month's worth of interest on it. So that essentially, this is the payment she makes at the end of January 2022. So this is Jan 2022's payment. And that will be made at the end of January, which means there's only 1 month of interest on it. The next payment then, 685.42. This is February 2022's payment. So that will include the same interest, but 2 months of it. Okay? And then keep on going, March, April, May, into 2023, so on. And then her final payment will be the same amount, but it will include 4 years. So these are months, so 4 by 12. So we're talking about 48 months worth of payments. Okay? Okay, so the way you do this, the way I do it, there's loads of ways to do it. I always take out the top line as a common factor. Okay, so the 685.42 is going to be in every term, so I take that out. And that leaves me with 1 over 1.00425. That's the first one. Plus 1 over 1.00425 to the 2. All the way down to 1 over 1.00425 to the 48. Okay, and this bit here is your geometric sequence. Okay, so I go into my book. What page did I say? 22. Yeah. So here is the formula that I want. It's a geometric sequence. So I'm going to go back here and I'm going to apply this. Okay, so I'm just going to do it in a different colour. So A is the first term of the sequence, which is 1 over 1.00425. And R is the common ratio. So the way you get the common ratio is you take the second term and you divide it by the first term. Okay, and if you take that second term and divide it by the first term, this is what you get, 1.00425. Okay, and we know that whereas n is the number of terms in the sequence, we know there's 48. Okay, so throw all that in. A is 1 over 1.00425. 1 minus 1 over 1.00425 for R to the power of 48. And then that's all over 1 minus 1 over 1.00425. Okay, so that is A, R, and 48 subbed into this formula here. Literally just calculator that. And you get, I don't have the whole number written, but it's 43.337, and it like keeps on going. Okay, so that there, use the highlighter, that is the answer to this here. Okay, so I can now go back and literally, instead of that bracket of mess, I just replace it with this number. So I'm doing 685.42, and I'm going to multiply it by this number, which I've kept in my calculator. And when you do that multiplication, you figure out that she still owes €29,704.50. That's what she still owes at the start of 2022. All right. So where are we now? Is that right? Yeah, there it is there. 29,704.50. Okay, so now we're on to this one. Calculate to the nearest cent the amount that she will have to pay monthly Okay, so when you're working out what she has to pay monthly, it's that sorry, now I have to go back to it. The amortization formula. So I'll throw it in here again just so we have it. Right, so A equals, so the principal for these last 4 years is the money that's just to pay off in the 4 years, which is that number we just figured out, €29,704.50. Yeah? Now, the interest. So, this is now a monthly repayment, and this new interest, where did they say it? Here, was 4.4%. But that was a yearly interest. So just over here, we'll just do it in black. We need to change the yearly interest into a monthly interest. Yeah? So we use that same formula that I showed you earlier. Well, I've written it backwards, but it's the same thing. And again, we do the thing where we make P equal to €1. So we've 1 plus I. Now, this time, it's different. We're talking about there's 12 months in the year because we're going the opposite direction. And again, what did I say? It was 4.4%. So you're taking your €1 and you're going to add, so you divide it by 100, multiply it by 4.4 and add that amount back on. Sorry, I already have this calculation done. Hang on. Yeah, so when you do that, you get 1.044. Same as before, the 1 is kind of obsolete, so you can ignore it. So 1 plus I to the power of 12 equals 1.044. I want to get rid of the power of 12, so I use a square or a root, a 12th root. Take that out. Sorry, it's in black. So that's 1 plus I, and when you do that 12th root, where is it now? I am getting 1.00359 You take the 1, bring it over, it's a minus 1, so I is 0.00359. And that's now my monthly interest. So you just have to remember those really. It's using the same formula twice, but when you're going monthly to yearly, which we did earlier, the power is a 12th, and when you're going yearly to monthly, the power is 12. That's the only difference. That's all you really have to remember. Okay, so now I can go back to my formula. I know what the interest, so I'm on that I there, and I now know what it is. It's 0.00359, 0.00359. Okay, then, next bit is the I, but plus 1, so it's 1.00359 to the power of, now what did we say was left? 4 years, so that's 48 months, and then that is over 1.00359 for this bit, again to the power of 48 and minus 1. Now the 0.00359, I should say, has more digits, as in that's not it. So I used my calculator and held all the digits, so made it as accurate as possible. So if you do that and hold all your digits, you get €674.88. If you round it, for example, to 0.00359 and you stop there, you will get a slightly different number here. Now it should be, like, from a getting marks point of view, it should be absolutely fine. It's just where possible if you keep all the digits. So that's that one, which I think I checked. I did. There's 674.88. So nearly there now. And this is 8C part 3. Just move right down here. So calculate the total amount of interest that Meg will pay over the term of the loan. So for her first 6 years, she was paying €685.42. Again, this has to be in months because that payment was per month. So that 72, is it? Yeah. Okay, so we multiply that by 72, and I have a total for that of €49,350.24. And then for the last 4 years of the loan, which again has to be in months, we just figured out that she's going to pay €674.88 and multiply that by the 48 months, and you get €32,394.24. So combine them, add them, and you get 81,000. That's not an 8. Hang on. So you get €81,744.48. The loan was for 60,000, so that means she paid €21,744.48 in interest. Okay, and then what advice would you offer her? And justify your answer with calculations. So I don't think it was entirely clear what they were getting on here. I think I know what they mean. So that, where they offered her that lower rate up here, they said that they'd only give her the lower rate if she made all her repayments up to date, on time and in full. So obviously if she missed a payment at any point, she wasn't going to be able to avail of that different interest rate. So I basically just didn't split it. I just imagined she did the entire 10 years at the original interest rate. So her original repayment was $685.42, and I did that for the whole 10 years, which is 120 months. And where did I get that now? €82,250.40 is what she would have paid in full, minus off the 60 grand that she actually borrowed, meaning she would have paid €22,250.40 in interest. So that's clearly a higher number than this number. So I minus them. €22,250.40 minus €744.48. And when you minus them, it comes out to be €505.92. So if you advise her to stay up to date and pay all her payments, and as a result can avail of that lower interest rate, then she'll save herself just over €500. Okay, hope that all makes sense.